Moles and gases. So now moles and gases, that's your next formula, which is simple that you've done that before previously. It's just that 1 mole of gas occupies 24 dm cube at RTP. So whenever you have 1 mole of gas, it's always going to occupy 24 dm cube at RTP. So you can continue to use ratios, or you can just use the simple formula. Like if you have 2 moles of gas, the volume occupied would be 48 dm cube. If you've got 10 moles of gas, the volume occupied would be 240 dm cube. So you can either keep on using ratios by looking at the moles of gas, you can figure out the volume of gas, or you can use this formula, which is moles is volume of gas divided by, and remember this formula is for gases only. So it's the volume of gas divided that by 24 dm cube. So this formula over here will solve your ratios, but you have to be quick. You have to be quick. Like if you're given the volume of gas, you divide by 24 immediately to find moles. If you're given the moles and you're being asked to find the volume of gas, you will multiply by 24 and you'll find the volume of gas. So for example, if I have, can you even quickly do this? If I have 0.56 moles of any gas, let's say moles of N2 gas. So what's the volume?
$13.44.
Okay, so it's going to be 13.44. I mean, you're going to round it off to 13 dm cube. Okay, that's going to be your volume, because your original number was accurate up till 2 significant figures. So you can't have a more accurate answer than that. As anyway, so that's going to give you your volume. Similarly, if you're so that's one. Let's do another one. Let's have I have 500 cm cube of a gas. And remember, the volume must be in dm cube. So how many moles is this?
Uh, 0.20.
Can you confirm? 0.20. It's
मैंने 500 को divide by 1000 किया है.
Even then you're not going to get 0.20. Remember, moles would be volume of gas, 500 cm cube. It should be in dm cube. Okay? So moles of gas is volume of gas divided by 24 dm cube. So what do you get? Okay, it's volume of gas divided by 24 dm cube. So what do you get over here? You quickly bata do कि what are you getting?
0.20.
0.02.
And 3 significant figures. Is there any? I mean, this is the original value was 3 significant figure accurate. So, is there anything after 0.02, or is it just exactly 0.02?
So 0.02, 08.
2 and then 08, right?
Yes, sir.
Moles. Okay, just be careful. If the original value is accurate up till 3 significant figures, your answer should be written up till 3 significant figures. That's the least accuracy that they're going to have. So that's the formula. Okay, it's a simple formula. You know the volume of gas, you can figure out moles. You know moles, you can multiply by 24, you'll find the volume of gas that you have. The only problem in this is compared to O-levels, in O-levels, everything was RTP, right? Just make sure that whatever they're talking about, is it at RTP or not? You have to make sure, because in A-levels, not everything would be at RTP. So make sure things are at RTP. I mean, don't blindly just use this formula. You have to be very careful that the things that you're dealing with, is this at room temperature or pressure or not? Because remember, gases can expand and they can contract. Like if you increase or decrease pressure, if you increase temperature, decrease temperature, the volume is not going to be 24 dm³. It's only 24 dm³ at RTP. That's it. So make sure the things are at RTP, because in A levels you're going to study later on in a different chapter that things might not be at RTP in the first place. So then if not at RTP, don't use this formula. That's it. Don't use this formula, because 1 mole of gas would then, it will not have 24 dm³. The volume will not be 24 dm³. So don't use this formula. So be careful about that. Okay, in O levels, everything was by default at RTP, but now it's not going to be at RTP. And so that's it. So we figured out, I'm going to sum up all the moles formulas that we have done. Just very quickly, moles is number of particles. Divide that by the Avogadro's number. Or 6.02 times 10 power 23. Then we had moles is equal to mass divided by AR or MR. And we had a discussion on AR and MR, what that thing represents. Then we had moles is equal to volume into concentration. That's specifically for solutions, where the volume must be in dm³. Everything must be converted into dm³. But the last one that we did is for gases. Remember, this volume is the volume of solutions. This other formula is the volume of a gas. You divide that by 24 dm³. So anyways, these are your 4 formulas for finding moles. Remember, all your counting would be done in moles. You're going to have 2 moles of substance, 3 moles, 2.5 moles. Everything would be counted in moles. So let's start talking about ratios now. Let's start talking about what would happen if we calculate moles. So now we're going to talk about equations. And we're going to talk about, yes, Maz.
Sir, you said that if it's not in the RTP, then can't do it. So what's the vice versa of it?
We'll study that later, okay? But just remember, for now, just remember that if things are not at RTP, don't use this, okay? You will a formula 1 mole 24 dm³ thing. It's not going to work in that case, okay? If it's not at RTP, we're going to study that later, okay? So now this one, moles, equations, and ratios. Now remember, all the counting is being done in moles. Okay, we learned how to calculate moles, whether it's from a gas or a solution or a mass is given. So we know the formulas, how to calculate moles. Okay, we know how to calculate quantity. Now the thing is, what if you're given ratios? For example, I've got this thing. An equation is like a recipe. It gives you the ratio in which things are going to mix up, and in which so it's going to be just 1 second. Let me make it 2. This is going to be 3H2. So this would be double as well, and this would actually become 6. TK, can anyone double check? Is this a balanced equation? So you've got this equation, and the equation has been balanced for you. Now the equation is a recipe in which it tells you the simplest whole number ratio, that 6 sodiums are supposed to be reacted. I mean, they're going to react with 2 phosphoric acid molecules, and they're going to form 2 sodium phosphates and 3 H2 gas molecules. So that's the ratio in which things are going to mix up, and in the things, the products are going to be formed. So if I have, let's say 600 sodium atoms. So according to the recipe, how many phosphoric acid molecules should I use in the reaction? What's the ratio?
200.
Okay, that's going to be obviously 200. And what are the products? In what ratio are the products going to be formed? This one would be What?
200.
Okay, this one would be 200 and the last one would be 300. Okay, so the point is that it's like a recipe in which things are going to be mixed in a certain ratio, and the products are going to be formed in a certain ratio. And this ratio is the ratio of moles. Remember, it's not the ratio of mass. It's not the ratio of mass or any other thing. It's the ratio of moles. It's the ratio of quantity. Okay, for example, remember, it's the ratio of the quantity. You're counting things. I mean, if you have got two people, one person standing over here, and there's two, or let's say there's another person on the other side. What's the ratio? What's the ratio of the quantity? That's 1:1, right? But the mass of the two people can be different. Okay, but the quantity is 1:1. There's one person on this side and there's one person on the right side. So you get my point. Like if you're mixing molecules, the ratio is the ratio of the number of particles. It's the counting that you're doing. Okay, you're counting things in moles. So you're going to have 6 sodium atoms and you're going to have 2 phosphoric acid molecules. It's not the ratio of the mass. It's not the ratio of any other thing. It's the ratio of moles. So be very careful. Okay, don't use this ratio for mass or for volume or for any other thing. Okay, so this is the ratio of moles. So if I give you 0.56 moles of sodium, can anyone tell me what's the, according to the recipe, how many moles of phosphoric acid should I add over here?
.19.
Okay, so it's going to be 0.19. What you're going to do is you can either take the longer route, use 6:2, then 0.56 ratio x, and then you'll cross multiply, and that's how you're going to find x, which comes out to be what? It's going to be 0.56 multiplied by 2, and I think divided by 6, right? So Sidra, what did you get?
0.19.
So you got 0.19 moles. Is it clear to all the others as well? Clear here? Everyone else?
Yes, sir.
Yes, sir.
So the only problem with this is that it's just too time consuming. You have to be quick. Okay? In A levels, you have to be very quick. So the simple method is, I mean, you're going to use ratios, you're going to do this thing, but just don't write it down. Don't waste your time. Okay? The simple answer is, I mean, that's the method. Like if I want to find the moles of all the other substances and I know the moles of this substance, it's going to be 0.56 divided by its ratio 6 and multiplied by the other one. And you'll find the moles of this one. If I want to find the moles of this one, it's going to be 0.56 divided by 6 into 2. So it's going to be 0.56. Divide that by 6 into 2. Okay, that's the quick method. Okay, just don't waste time. Just be very quick. 0.56 divided by 6 into 2. If I want to find the moles of H2, it's going to be 0.56 divided by 6 into 3. Divide by 6 into 3. What do you get for this?
.28.
So you're getting 0.28 moles for this. And what about the next one?
No, the last one is 0.28.
That's the last one is 0.28. Was the first one before that?
उसका same नहीं होगा वो 0.19.
Okay, that's going to be 0.19 moles. Okay. Anyway, so you have to be quick with ratios as well. So we can try another one. Let's say I've got P2 reacting with O2 and it's forming P4O10. Now the ratio is the equation is balanced this way, that it's going to be 2 P2 molecules. There's going to be 5 O2 molecules, and that would give me exactly 1 P4O10 molecule, right? So I have the ratios. Let's say I have this is 0.85 moles. Okay, now you have to be quick. Okay, you can use ratios, but just be quick. If I want to find the moles of this one, you know the moles of one substance, you can figure out the moles of all the other substances. It's going to be 0.85 divided by 5 into 1. So this is going to be 0.85 divided by 5 multiplied by 1. If I want to find the moles of this thing, it's going to be 0.85 moles divided by 5 into 2. 0.85 divided by 5 multiplied by 2. So what do you get for P2? How many moles do you got?
0.34.
Okay, so you're going to get 0.34 moles. Or the next one is what do you get for this one? It's going to be
0.17.
0.17. Okay. So just remember, the whole moles question is this thing. You find the moles of one substance in the equation, you can figure out the recipe then. You can figure out if you find the moles of one substance, you can, by using ratios, you can figure out what quantity you're going to obtain, what is the product that's going to form. What is the quantity that you're going to cook it with, the amount of phosphoric acid. So the whole idea is you have to find the moles of one substance. You'll be able to figure out the moles of all the other substances. So let's do another one. As this one is, I've got 6 NaOH reacting with 3 Cl2 gas molecules, and it produces NaCls, 5 of them. And it produces NaClO3, and it produces 3 water molecules. So now what's going to happen? Let's say I know the moles of this thing. I know that this is, let's say, 2.25 moles. Now quickly tell me the moles of all the other substances. So if I want to find the moles of Cl2, 2.25 divided by 5 into 3. Tika, what do you get?
1.3.
1.35.
Tika, you get 1.35 moles. And remember, I'm stressing this over and over again. You've got very little time. In the AS, for every question, you've got very little time. You have to be quick. You have to save time whenever possible. Tika, you have to be quick with your calculator, everything. So what about this one? It's going to be 2.25 divided by 5 into 6.
2.7.
So divide by 5 into 6, and that gives you 2.7 moles. What about this one over here? How many moles? 2.25 divided by 1 into divided by 5 into 1.
0.45.
Into 1, that's 0.45 moles. And then the last one, that's 2.25 divided by 5 into, and you can use any ratios. Like if you know the moles of this one, 1.35 divide by 3 into 3. So it's going to be the same thing. Right? Is this clear? Is this, so this is clear to everyone, right?
Yes, sir.
Yes, sir.
So now I'm going to link this with the formulas. TK, remember the whole question is this thing. The first thing is you need to know an equation. Sometimes the equation would be given. A lot of times the equation will not be with you. So you need to know, or you need to learn how to make the equation, because without the equation, without this recipe, you can't really do much. TK. So the equation is the first thing. TK, you have to be good with equations. TK. If it's given in the question, then that makes like 50% of it is now, it's already done for you. The second point is, you have to find the moles of any one of the substances. If you're able to find that, you can find the moles of everything. The rest is just these formulas. Like once you have moles, you can convert the moles to number of particles. You can convert the moles to mass. You can convert the moles to volume or concentration or the volume of gas. So the rest is easy. That's just these 4 formulas. Okay, so let's try and do an actual question. Okay, for example, they've given us that there's 25 grams of calcium carbonate that's reacting with 400 cm3 phosphoric acid, which is a solution. I mean, that's the information that's given. And they're asking you 3 things. They're asking you to find concentration of the phosphoric acid. They're asking you to do that. Number 2, they're asking you to find the mass of salt that is produced. And the third thing is they need to find, they're looking for the volume of carbon dioxide gas that's produced. Okay, so remember the whole task is find the moles of one thing, you'll find the moles of everything. Okay, so let's start. What's calcium carbonate with phosphoric acid? Let's start with the first thing, the equation. Can you tell me what the salt is in this case that's going to be produced? Carbonate plus acid produces salt, water, and carbon dioxide. So what's the salt?
Calcium phosphate.
phosphate.
Okay. So you got water, you got carbon dioxide, and there's going to be calcium and phosphate. Make sure you do the crisscross again. Calcium is 2 plus, phosphate is 3 minus. So this is going to be CH3 and PO4 twice. Okay. So we're almost done with the equation. We need to balance this equation. So we're going to try and balance it. So it's going to be 3 calciums, 2 phosphoric acids, 3 water molecules, 3 carbon dioxide molecules. Okay. Now tell me, based on the data that's given, okay, look at the data that's already provided to you. 25 grams of calcium carbonate and there's 400 cm cube of phosphoric acid. Whose moles can you find out? Like, can you find the
Calcium phosphate.
Calcium.
you can find the moles of this thing, you can find the moles of calcium carbonate, okay? Because the mass is given. So what you can do is moles is mass divided by, so the mass is given 25 grams divided by the MR. Now remember, I told you that the MR has to be very, very specific. Calcium in the periodic table is 40.1 and the other one is carbon is 12.0 and oxygen is 16.0 times 3. So what do you get? It's 25 divided by 100.1, right? So how many moles do we get for this?
Zero 0.249.
So 3 significant figures. What's after 9?
97.
ठीक है, तो फिर then it's going to round off to 0.250. ठीक है, मतलब the third number would get rounded off. 7 upwards round होगा ना, so it's going to become 0.250. अच्छा, but remember, try not to round off things on your calculator. मतलब as long as possible, just don't round off things. ठीक है? Sometimes it would become too impractical, but just don't round off things on your calculator. So this is 0.250 moles, right? You found the moles of this. So you can kind of find the moles of all the other things in the equation. You can find the moles of everything in the equation now. So 0.250 moles divided by 3 into 2, you'll find the moles of phosphoric acid. So it's going to be 0.250 divided by 3 times 2. This one would be
0.16666.
अच्छा, 0.167 moles, ठीक है? You're going to get 0.167 moles. इसकी मैं थोड़ी सी accuracy ठीक कर लूं कि I'm going to change this to इसको उठा लो. So I'm going to change this to 25.0 just to keep things so that our accuracy is not disturbed, ठीक है? So I'm going to change that to 25.0. So my numbers cannot exceed 3 significant figures now because my original numbers are accurate up till 3 significant figures. What about the next one? I can find the moles of everything. Let me do that. It's going to be 0.250 moles divided by 3 into 1. What do I get for that?
Zero 0.083.
Okay, so you're going to get 0.08. 3. And is there anything after 3? 3 significant figures.
333 recurring.
Okay, this moles. So I just wanted to check if this is the exact number, just for accuracy's sake. Okay, just 1 second. Where's the calculator? Okay, just to show you. It's 25 divided by 100.1. So 25 divide that by 1000.1, and I get this. And then if I want to find this, I'm going to divide that by 3. So if I divide that by 3, I get this. So it's, and it will be 3.08. I'm going to round it off at the third one. So the 5 will get rounded upwards. So it's going to be 0.0833. Okay. So just follow this. I mean, try not to round off things. Keep the on your calculator, keep the things wherever. I mean, don't round off things on your calculator. So, but anyways, we are still getting 0.0833. So what about the moles of these two things? They're going to be the same, 3:3. So that's exactly the same. This would be 0.250 moles. These ones over here. Okay, they're going to be 0.250 moles, and carbon dioxide would also be 0.250 moles. So is this clear? Okay, we found the moles of one substance, and using their moles, we were able to find the moles of all the other substances. Okay, clear?
Yes.
Yes, sir.
So what do we do next? Find the concentration of phosphoric acid. For phosphoric acid, we know the volume as well. Now, the rest is just formulas. Moles is concentration times volume, right? So we have the moles. So that's 0.167. We don't have the concentration. The volume is given as 400 cm cube, and that would be divided by 1000.4 dm cube. So you can use that and you can find the concentration. Now, what do you get for that?
.4175.
1.8 mole per dm cube, right? Okay, just remember your answers cannot exceed the accuracy that's given over here. Okay, if it's 3, keep your answers within the 3 significant figure range. I say he was asking for the mass of this thing, calcium phosphate. So you can find that moles is, I mean, you know that moles is concentration, moles is mass divided by AR or MR. Or MR. So we have the moles, it's 0.0833. And I'm going to multiply it by the MR. Calcium is 40.1. And there are 3 of them. Then you've got 2 phosphoruses, that's 31.0, and there are 2 of them. And you've got 8 oxygen, so that's 16.0 times 8. So what is the mass that we are getting?
310.3.
Into 0.0833, what do you get?
25.85.
Which would be 25.9 grams. Okay. And the last one was he was looking for the volume of carbon dioxide. So moles is volume of gas divided by 24 dm cube. So that means the volume would be the moles multiplied by 24. So it's going to be 0.250 moles multiplied by 24. And that's going to give you the volume, which is going to come out to be what?
Six.
6, RTK. That would be 6.00. You can remember, keep the accuracy. It's going to be 3 significant figures. I mean, that's going to be your accuracy, okay? So it's going to be 6.00 dmq. So is this clear? You find the moles of one substance in the whole expression, you'll be able to find the moles of everything using ratios. TK, And then it's all just formulas. TK, whatever they're looking for, use the appropriate formula and you'll find the mass, the volume, the concentration, and or the number of particles. TK, is this clear?
Yes, sir.
So try and do this question now on your own. Like, here's another question. I've got aluminium. So 10 grams of aluminium, but you forget the aluminium. Aluminium reacts with 0.25 mole per dm cube sulfuric acid. And ends up producing and produces 1500 cm cube of H2 gas. So they are asking, number one, they're asking for you to find the mass of aluminium that has reacted. Number two, they're looking for the volume of sulfuric acid that's going to be used in the reaction. I mean, that's it. These two things. So the first basic thing is start with the equation. It's going to be aluminium reacting with the sulfuric acid. The salt that's going to be produced is going to be aluminium sulfate. So Al is 3 plus, group 3, SO4 is 2 minus, so it's going to be Al2, and SO4 would be thrice. Plus, there's going to be hydrogen gas. Metal plus acid reaction produces H2 gas. So there are 3 sulfates, 2 aluminiums, and there would be 3 H2 gas molecules. Okay, so we've gotten our equation. Now, whose moles can we find out in the whole from the data that's given? I mean, you're given two things. The concentration.
H2.
So it's the volume of gas. You can find the moles of H2 gas, because moles is volume of gas, which in this case is 1500 cm cube, which should be in dm cube. In dm cube, that would be divided by 1000. So it's going to be 1.5 dm cube divided by the molar volume, which is 24 dm cube. So how many moles do we get for this?
.0625.
So we get 0.0625 moles. I'm just going to add a third significant figure. So all my numbers, all my answers should be accurate up till the least significant figure, which is 3 over here. So I found my moles. Then finding the other moles would be very easy. H2SO4 would be exactly the same. Aluminium would be what? 0.0625 divided by 3 into 2. So what do you get?
.041666.
So 0.0417 moles. So you found the moles of these two substances. The rest is easy. They're asking you to find the mass of aluminium. So try and do that. It's going to be mass is moles. Multiplied by the AR, which is for aluminium is 27. That's going to give you mass. What do you get? What do you get for this?
1.125.
So you're getting 1.125 grams. As they're asking for the volume of sulfuric acid. So that's we're going to use moles is equal to concentration times volume. We have the moles, it's 0.0625 moles. We have the concentration that's also provided, it's 0.250. So we're going to find the volume. What volume do we get for this? Kevin, what are we getting?
0.25.
For this one, 0.25?
Yes, sir.
0.0625 divided by 0.25. Are you sure? Don't you, I just check 1 second. 0.0625 divide that by 0.25. And that gives me 0.25 exactly. TK. So we're getting 0.25 and that's dm cube. TK, remember, if they're looking for cm cube, multiply that by 1000. So you find your answers. TK found your answer. So the whole key is you find the moles of one thing, you'll be able to find the moles of all the other substances. So I'm going to do, I'm going to write down a reaction. TK, I'm going to give you a reaction. There's 30 grams. This is your homework. 30 grams of ammonium phosphate. Like if you're not able to find the equation or write the equation, you can always refer to the internet. You can find the equation. So there's 30 grams of ammonium phosphate reacting with 0.15 mole per dm cube NaOH. So you're supposed to find concentration of NaOH. So then you've got to find the mass of salt that is produced. So you've got to, now tomorrow we're going to start with past papers, TK, for moles. Subtopic wise, we're going to find the mass of, not the mass, we want to find the volume of ammonia gas that's produced. TK, that's your homework, TK. Let me just post this in the classroom.
Sir, tomorrow same time or in the morning?
Yeah, I'll let you know the time, TK. Just 1 second. So it's this one, I think. TK, so just 1 second, let me just. TK, that's the question that you have to solve. I've posted it. So moles question basic, and it's due tomorrow. And that's your first moles question. Tomorrow we'll start with, TK, I've assigned it as well, and I'm going to post it in the group as well. TK post kar diya. Chaliye, let's continue tomorrow then. Okay, everyone.
Okay, sir. Allah Hafiz.
Okay, sir. Allah Hafiz.
Take care.
Allah
Love.
Hafiz, sir.
Hafiz.
Thank you, sir.